So, hello guys, welcome back to my channel. And those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. Just let me check the voice ones. Okay, so we started a 7 days Python course for you all, in which I would be teaching, Python, which is particular to the data science and also, for the absolute beginners. So I started series regarding that, and I successfully covered the 6 days of the Python, and today is finally the day 7 of this course. We decided to just go live and live code in front of you about the ED. So we will be using a website known as the Kaggle, from where we will be like taking the data set from there. So you can just log into the Kaggle. You just have to type Kaggle in the search bar and click on the first link, and clicking first link, just log in with your email account and just go to the data set there, and you will find the latest data set, which is like vitamin deficiency diseases prediction data set. And I will just put the link of the data set in the description of the video also, so that you can access it. So you can uh, create the notebook in the Kaggle itself also. So anyone can have the access to your notebook in the Kaggle, and anyone can look at your notebook if you have made it public. And you can also do the EDA in the Google Colab. So in the past 6 days, we have done all the EDA in the Google Colab. So now we will be doing it in the Kaggle notebook only. So for creating the notebook in the Kaggle, just click on the new notebook. And if you're working on the Google Colab, just click on the download and just copy this and place it in one of the code cell of the Google Colab, and your data set will be accessed from there. But for here, you just have to click on this, three dots, create a new notebook, and your new notebook will be created. And we can just name this EDA as like vitamin deficiency, isn't it? So I have named this Kaggle notebook as the vitamin deficiency analysis. And just do this stuff. I'm giving you 5 to 10 minutes to just log into your Kaggle notebook and create a new notebook, so that you can ensure that you are practicing with me and you're not left behind actually. Okay. So let me write just markdown cell till then. Okay, so we will be doing like exploratory data analysis on the vitamin deficiency diseases prediction data set. So let's discuss first like what we are going to cover in this. So in the slide session, no, we will understand the data set structure, identify the numerical and the categorical features, perform the univariate and the bivariant analysis, detect the missing values, outliers, and the correlations, and prepares insights for the machine learning. And if you want to show your notebook to the everyone who is reviewing this data set, just set it public so that they can have access to it. And if you share this public URL with anyone, so anyone can see your notebook. Okay, so you can click on just save. Okay. Okay, so Let me just put, I think, the link of the live also here so that anyone can identify that it's my notebook and can refer to the video. Okay. So let me just put the YouTube link here. Okay. Okay. So clicking on this link, you can access to my live session. So let's just talk about this first. So welcome everyone, and in today's live session, no, we are going to perform proper exploratory data analysis on a real medical data set. And EDA is not about plotting the random graphs, and EDA, which is known as the exploratory data analysis, is about understanding the story hidden inside the data before we even think about the machine learning. So let me import some libraries first, as you're familiar with all the libraries. And if you're not familiar with the libraries, just make sure that you watch the video from day one so that your process is smooth as possible. Okay. So let's just import the libraries first. So I'm importing NumPy as NP, and I will be utilizing Panda. So I'm importing that as PD. Now let me import some visualizing libraries through which I can visualize my data set. So I will be writing import matplotlib dot pyplot as plt and import cbon as sns. Okay. Then often we get certain warnings while doing the data set also. So my video is not clear, I guess. Is it? Let me just check that first. It's pretty clear now, I guess. Maybe because of the network issue. Okay, so let me just import so that all the warnings, are ignored, and you are not scared of warnings if it comes, because warnings are not errors; they are just warnings. So let me import like warnings dot filter warnings, and then write ignore. Okay. Now let me just run this here. And I will just write a command here like print and all the libraries. Okay, let me just write it here like this. All the libraries are imported successfully. Okay, now window period and the text. Okay, so it's good to go now. And hope you guys are just following me and you're not left behind. So we are intentionally using the NumPy, the Matplotlib, the Pandas, and the Seaborn. And if you're reading from now, you don't need any fancy libraries. Okay, just as basic libraries are enough, like the NumPy and the Pandas and all. Okay, now it's time to just read the data set quickly. So we are reading the data set using the df is equals to pd dot read csv, and we will just read the data set like this. Okay, then this, and just copy this path so that you can read the data set here like this, and just hit enter. Okay, we are getting a small error. Let me just go through the error right away. Okay, we I'm not put the dot C. Okay, yes. Having trouble finding Wi-Fi, finding your files tutorial. Okay. I think it's not able to read the file, just a case. Let me, I think, copy this maybe. Okay, now it's okay. So you have to copy this path. Okay, now just copy this path and paste it here, and your data set will be read. And if you want to, just see your data set, you can. Okay, I will, introduce that in the next step. So let's just first look at the data set. Okay, so just first look at the data set. Okay. Through this, we can look at the data set. How, as I told you in, I think, I guess in day two or day three video, we look at the data set using df.head and just hit shift and enter. So we have, several columns like the age, gender, BMI of a person, smoking status of a person, and then exercise level, the diet type, the sun exposure, income level, latitude region, sight blindness, fatigue, blah, 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 blah. So we have a pretty long data set, okay? So let's just look at the shape of it, okay? So df dot shape and just hit shift and enter. So this data set basically has 4,000 rows and 34 columns in total. And let's also look at the info of the data set like df.info and just hit shift enter. So as we can see, there are not any null values here in that. So here I'm checking the three things basically, that how many rows and columns we have. So we have like 4,000 rows and 34 columns in total, and what kind of the features exist through the columns we can see, like we have various features like exercise level, consumption, smoking status, age, gender, BMI, etc., and whether the data types are already machine friendly or not. Okay, machine friendly means they are having like so in the later classes you will also get to know about the machine learning if you wish to learn. So I'm seeing that only, and this step alone saves hours of debugging later. Like we have, checked the columns, the rows of a data set. So a lot of time is saved actually. Okay. Now just move to the next step, which is the statistical summary of the numerical features. So if you have like attended my classes, already know how do we look at the statistical summary. Statistical summary of the numerical features. Okay, so we can look at it using the df dot describe. Just hit shift and enter. And this table tells us the range of the values, the average behavior, and whether extreme values might exist. Think of it this as a medical report of the data set basically. Okay, so you can transpose this also using dot t, and you dot t, you will get a tight layout of this whole, and you will not get in like rows. You don't have to scroll basically. You get this like the max, for example, the maximum age in this is 24 and the minimum age in this data set is 18, and the minimum BMI which exists is 15 and the maximum BMI which exists is 45. So you have to basically understand your given data set when you're doing the EDA. So first try to understand your data set. Okay, just look at the rows, look at the columns and the info, and then look at the statistical summary of it. And then finally, it's time to like analyze the missing values. Okay. So we will just analyze the missing values. So missing value analysis. Let us shift and enter. And how do we know the missing value? So we want to calculate, like we want to see the missing values. For that, we would be saying null values. So for that, we will be writing df dot is null and then bracket. And then we want to just know, like, does it have missing values and how many missing values it has. So we are writing dot sum. So just to calculate the sum of it. So as we can see here, the alcohol consumption is having like 1278 missing values, which are basically, NA values or the null values. And the simple list is having like 1, 3, 2, 8 missing values. Okay. And if we want to, calculate the length of it, we can also use the code. Like you have to type like df dot is null. Okay, we would be typing is null, then sum, then just put this slash and divided by the length of the df and then into 100. Like how many, when we have to calculate like how many percentages of the null values we are having in total. And we will just keep this in a double bracket. Okay, so that is for phrase error. Yeah, so two brackets. Okay, two brackets. Okay, okay. So as you can see, like in alcohol consumption, there are 31% null values, and in the symptoms list, there are 33% null values. Real world data set missing values are very normal, and our job is not panic. Our job is to identify and plan like how to handle these missing values. Then we have to obviously check the duplicate values also. So checking the duplicate values, we will be writing like, but let me write the markdown so we are not confused later when you are looking at this data set. Check. Just hit shift and enter. And let me see the missing values also. df dot duplicated, then the brackets, then the sum, and then this, then hit shift and enter. Okay, so there are no duplicate values basically in this data set. So duplicate record na silently damage the model performance. So always check this before moving forward. Okay, now we have to, basically separate the numerical columns and the categorical columns. Okay. So this step is, basically necessary when you are doing the machine learning and you're already familiar with, machine learning or have started doing the machine learning algorithms, already know that how it is important to separate the numerical columns and the categorical columns basically. Oh, also that's why it's a part of the EDA, and I've kept this part purposely so that all of you can know like how to separate the numerical columns and the categorical columns. So numerical columns, I'm writing numerical underscore false. Then I would be like df dot select D types. Okay. And if you want to know like what does this D types do, you can just, I will just show you here. You will write the df.d types and see it's basically showing me na that how much like which are like the numerical columns and which are categorical columns. Okay, so D select D types, then we will be writing include is equals to NP dot number, that I have to include the NP. Obviously, if we are separating like numerical columns, so we will be including the numbers, so the number columns, then dot columns, and just hit shift and enter. If you want to see like what this, what does this print, you can like just run this here and you will be able to see. So these are all now basically are our numerical columns. Like as you can see here in the data, like age is having the numerical column, like the age, BMI, and we are having like night blindness, bone pain, all are having like numerical values. So all are included here. Okay. Now we have to separate the categorical columns. For the categorical columns, I'm writing categorical underscore false and then writing df dot select the types, then include. Okay, I have to exclude basically. Exclude because I have include, I'm doing like the categorical columns here. So I have to exclude the number column. So I will be writing exclude np dot number, then dot columns, and just run this cell. And if you want to see like what are the category columns, you can just insert another code cell behind and see the category columns. So gender, smoke status, alcohol consumption, exercise level, all these are basically the category columns. I will just print the output of these calls. So our numerical columns are. So we will just write a small message also here. So it looks professional basically, the numerical call. Just put slash in so that all the columns are printed in next line basically. Okay. And we will be writing like numerical columns. We're writing here numerical columns. And for the categorical columns, we will be writing the category. We could just copy and paste this line here. And categorical and just here write categorical. See how easily we did it. And if you want to separate these two, just write print and this. Okay. Now we are good to go. Okay. Now let's just check. I think there's a voice issue in this. Am I audible? Can anyone confirm that if I'm audible or not? Okay, the voice is fine. Okay, the voice is fine. Okay, now let's just move to next. So numerical categorical columns now don't behave differently. EDA becomes meaningful only when we treat them separately. Okay. So there's one, univariate analysis that we are doing the analysis of the numerical features. Okay. So let's just write that markdown first, the univariate analysis. So we will be writing like hashtag univariate analysis, and we are doing the basically analysis of our numerical features. So we will be writing that, and we just write the code for that. So for that I'm using the for loop. Okay, so we will be writing for call in the numerical columns, and we are doing the univariate analysis of the numerical columns. So numerical underscore calls, and then plt dot paper, and we can also give the fixed size here also, okay, but we will not give that for now. Then sms dot hist plot, then df that whole comma ad is equals to true. Okay, now let's just give the title to this plt dot title, and I would be giving title as distribution of, and I will be writing here false, and then I will be writing plt dot show. What technique I usually prefer is that I don't prefer giving the figure size every time I, draw the graph. Instead, I like to give the figure size in the beginning itself when I'm importing the libraries. Okay. So let's just give the figure size there only. So it's very useful. Like you don't have to give the figure size again and again. You can just write plt dot rc parents. Okay. Yeah. Then the figure, like figure dot fig size, and let's keep the fixed size basically like 6 comma 4. Okay, I think it would be great. Okay, so let me just, so I just like to give the figure size in the beginning itself so that I don't want to give the figure size again and again. Okay, so name columns is not defined. Okay, so I have basically made a mistake here. So just this. Okay, it's showing error again. Let me just look at the error first. It's trying to it's given me has no attribute. Okay, so str object has no items. Why is saying so? In numerical calls, blt dot figure sns dot history slot df call kd true. Okay, pretty cool. Okay. Okay, just ignore this error as our graph is shown. Okay, so we are having the age and the count of the people. Okay, so people who are having the age of 50 years are approx 300, like 20 years are approx 300, and people who are having the age of between 70 to 80 are approximately 250. Okay, so from these plots now, I want you to observe that is the data skewed? Is it normally distributed, or these values, or do the extreme values exist? Okay, so three answers, decide the scaling and the transformation later. So let's, detect the outliers using the box plots now. Okay. So detecting the outliers basically. So I will be writing outlier detection, detection using box plots. Okay. Now just let me look at all the columns. Let's for call in numerical plots, PLT dot figure, then SNS dot blocks plot, and X I'm taking as DF, then false. Okay, not false, basically only call. Okay, I don't know why I'm putting false again, and then PLT dot title. So this is a box plot. So I'm writing box plot of call PLT dot show. I think that's indentation error. Okay, I guess let's just run this and see if there's any. Okay, here it's exactly this. So this is a box plot of various. Okay, let's keep the same everywhere. Okay, just print command. Let's just keep this same everywhere so that we are not, having any confusion, right? So when I don't know what the error this Kaggle notebook had, but unfortunately when I did it, so uh, if you are curious to know like why I use the for loop, I use the for loop so that I can get all the graphs all at once, and I do not have to draw it again and again. So I simply use the for loop for that. So I've got the distribution of A, distribution of BMI, and and all the distribution basically in the form of a graph. So as you can see, like the people who are having the serum vitamin B12 ml higher in them, they are there. Okay. So we have got the distribution. Okay, now let's just look at the outliers, like which columns are having the outliers basically. So the column BMI is having some outliers as you can see here, and the vitamin A percent also are having the outliers, and like most columns are having. And so there is a greatest outlier among all. And okay, so many columns are having like many outliers. Okay, so box help us, visually detect the outliers, and outliers are always not bad, but ignoring outliers is bad basically. Okay, so we did univariate analysis of the numerical feature. Now let's do the univariate analysis of the categorical feature. Okay, so we were citing like hash univariate analysis of the categorical features. Categorical features. Okay. So we are doing the unique various analysis of the categorical features. Let's just copy the code. Maybe like we have to do a minimal changes in our code. So let's just copy it. So save the time basically. Okay. Now let me copy this code. Okay. This I can strictly jump here using this. Right. And for call in, I have to write here categorical columns. Then PLT dot figure is right. Okay, we are using the count plot because because there are categorical features. So we are using the count plot for this. So count plot x is equal to df. Okay, there's no need of this here. So we would just delete it. Okay, now let's just put the x also. X are basically the words on the x-axis. So we are rotating it 45 degrees so that, they are not overlapping with each other. So it's just a good practice to ensure this. Okay. And this is the count plot. So we will be writing here count plot, just hit shift and enter and see we have received the count plot of each and every. For example, the males are approximately 2000 and females are between like 1750 to 2000, and the smoke according to smoking status, like in the data, as per the data, among all the people who are present in the data set, among them approx 1300 like 50 have not smoked never, and currently the people who are smoking are approx 1300, and the people who were previously smoking are comparatively less. Okay, so this is how we analyze. Okay, so in this graph, this graph is trying to show that the people who are having the vitamin D deficiency, among them, approx the people who are consuming moderate alcohol are more than the people who are consuming the alcohol heavily. And looking at the exercise level, the among the most people are doing like the sedentary level of exercises, and the people who are suffering from the deficiency, the vitamin deficiency is among them. The most of them are vegan, and the like the count of the people who are suffering from vitamin deficiency, the most of them are vegan. Okay, and the people who are having a vitamin deficiency diseases, those who are are moderate to sun exposure are having the higher are having like a higher chances of having the vitamin deficiencies diseases. Okay, and the income level of the people whose income level is like low and high are more prone to the vitamin deficiency diseases. And the latitude, based on the latitude region, the people who are living in the low latitude region, high latitude region are more prone to the vitamin deficiency diseases. So this is count plot. Okay, this is like messed up. I don't think this is important, and this is the most important. And the people who are suffering from vitamin deficiency diseases, most of them are healthy. Okay, and like, and the minimum of them are having surgery. Some are having night blindness, and the percentage of people who are having the rickets and the Ostemalia are approx 1000. Okay, so this is all about the count plot. So here we are checking basically the class imbalance. So imbalance categories now directly impact the classification model. So we decided to just check the class imbalance in our data. Okay, now we are doing the correlation analysis. Okay, so let's move on to our next, that is the correlation analysis. So it will be like correlation analysis. Okay, and let's just draw the heat map. So for the correlation analysis now, we draw the heat map. So let's show you what the heat map basically looks like. So for that, we will be writing PLT dot figure, and I want my, the figure of the heat map a bit broader. Okay, so I'm giving the dimensions separately to it, because if it's, very shallow, then we cannot actually analyze. All the words will be overlapping. Okay, so infinite dot heat map. Then we are drawing heat map of the numerical columns. So numerical cols dot CORR and comma anode is equals to true, and C map is basically the heat map colors. So cool, warm. I'm keeping it as cool, warm. And I'm giving the title as PLT dot title. It should be correlation heat map. Okay. Now I will be writing just simply PLT dot true. Okay, I have variable value after star must be unitterable and not. Let me just check the code again. PLT dot figure, figure size is equal to, okay, I have made a mistake here. I have to insert the comma. Just run this cell. So this is basically the heat map. So correlation, does not mean causation, which means that two variables are correlated to each other. This doesn't mean that one variable is the cause of the other. Okay. I know this sounds really, puzzling to you, but it gives us a strong feature selection analysis signal. Let's just increase maybe the dimensions of this. It's looking too cluttered by the way. Let's see Let's 15. I think it would be really big now. Let us see. Okay, it's enough. I think it's really fine. So as you're seeing 111 here, because each variable is highly correlated to each other, so it's giving one, which means like that has muscle weakness and has muscle weakness. If you have these same variables, so these will be highly correlated to each other. So this is showing one here. So the darker the color, the more correlated variables are to each other, and the bluer the color, the less correlated the variables are to each other. For example, a person let's take this, a person whose vitamin A percent RDA, the is like I think highly correlated is between like zero point 0.4 to 0.6 to the vitamin C percent RD. Okay, so this is how you read the correlation heat map. And for example, like if a person has pale skin is like highly correlated to has fatigue and very low correlated to hemoglobin level. Okay, so this is a very important for giving us the strong feature selection analysis. So, what are the key insights of this EDA? So, moving on to the key insights of the EDA, like all that we have done here, and it's very important, to write the analysis of what we have done here. Okay, so let's write the key insights also. Key insights from the EDA. Okay. So, talking about the key insights, what we have seen here, the first was that the data set contains both the numerical and the feature columns. Remember, we have, separated the numerical and the feature columns. So, data set contains both numerical and the categorical columns. Okay. Now, some numerical features shows fewness and some shows outliers. Okay. So, some numerical features features show skewness and some show outliers. Okay, and you have like seen in the graph of the histogram, some features were skewed toward the right and some were skewed toward the left, and many of them were having the outliers, as you can see in the box plot. Like many features were having outliers, and while building the machine learning model, we have to treat these outliers separately. Okay, and we also saw that the categorical imbalance may affect the prediction. So there were also the class imbalances also. So columns, categorical imbalance may affect prediction. Okay, so categorical columns may affect prediction, and correlation suggests some important. And we also saw that our correlation, also suggest some important predictors. So our correlation suggests important predictors. And the data set is suitable for the classification modeling. We came to a conclusion that data set is suitable for classification modeling. Okay. Now, so EDA is successful. Okay. Only when you confidently say that understand my data. So what's EDA basically? EDA is about understanding your data, and only after this should the machine learning path begin. So most beginners, jump straight to the model beginning and all, but professionals spend a major time on the EDA. And if your EDA is weak, no, then your model will always be weak, no matter how advanced algorithm is. So this was all about the EDA session, and so let me summarize everything for you once. So in the starting, we saw one, okay, let me summarize this from the starting to you guys and explain to you. So today we did the exploratory data analysis, also known as the EDA, on the real medical data set related to the vitamin deficiency diseases. So EDA is, the most important step in the entire data science pipeline. And if it could be EDA, your model is just guessing. Okay, if your EDA is strong, even a simple model perform well. So today we We didn't rush into machine learning straight, and we are learning like how to think like a data scientist. And we imported some libraries basically. So NumPy we use for the numerical operations, Pandas we use for the data handling and analysis, and the matplotlib and the seaborn we use for the visualization. So seaborn is built on top of the matplotlib basically and makes the graphs more readable. So we also set it a default theme, okay, like the figure size, which I said it later, and warnings to ignore so that unnecessary messages, do not distract us. And this setup is very common, in the real industry data. When we read the data, that how we are loading the data set using the pandas. So an important rule is that never assume about the data before loading it, even column names and even data types and nothing. Okay, so everything we did next is based on the data actually contained and not what we accept. So then we looked at the data. Now this was a very important step. So the showed us the first few rows, and this helped us to understand what kind of values exist, whether data looks numerical or categorical. And the df dot shape told us how many rows are there, basically how many data points are there, and how many columns refers to the features. Okay, then we talked about df dot info, which is extremely important. It tells us the column names, data types, whether missing values exist or not. And most beginners skip this, and professionals never do. Then we talked about the statistical summary of the numerical features, and this table summarized all the numerical features. From here, we learned the minimum and the maximum values, mean and the median behavior, the standard deviation. And if the mean and median are very different, data is skewed. And if max values are extremely high, the outliers may exist. So think of it as a health report of the data set. Okay. Then we analyze some, missing values using these two commands. So missing values are, very common in the data set. The first line tells us which columns have missing values and how many, and the second line converts that into the percentage. We converted this into the percentage, remember? So this helped us to, decide to drop the column, fill the missing values, or leave them as they are. PDA is, about the planning decisions and not immediately fixing the things. Then we check the duplicate records, and duplicate rows means the same data point appears more than once, and this can bias the model, inflate the accuracy artificially. That is why we always check duplicates before modeling. Then we identified the numerical and the categorical columns. In this step, we extremely important. This step is basically extremely important because numerical and categorical columns behave differently and they require different visualization. They require different pre-processing. So first, clearly separate them, and this makes the rest of the EDA clean and structured. Then we did the univariate analysis, that is the numerical features, and this loop plots the distribution of each numerical feature. Like we do not have to plot each numerical feature writing separate code. We can just write the for loop and execute it, and all of the features will be plotted on a graph. And for these plots, we answer, is the data normally distributed, is it skewed right, is it skewed left, and are these long trails? And these answers decide the scaling, the log transformation, and model selection later. Okay, then we did like the univariate analysis of the categorical features. Okay, we did the, I think, univariate analysis of the category features. Okay, here it is. So box plots, visually highlight the outliers. So outliers, are also wrong, but ignoring blindly is really, really dangerous. Okay, so EDA helps us notice them early so we can decide it later. Then uh, and also the count plots also, this shows how frequently each category appears. If one category dominates, we have the class imbalance. For example, here the healthy category dominates, so we are having basically the class imbalance, and class imbalance directly affects the classification model. So even helps us to detect this before the training. Then we did correlation analysis. This heat map shows the relationship between the numerical features, and high correlation means that the features move together. So this helps in, feature selection, removing the redundancy. And remember that correlation does not mean causation, but it does give some direction. So key insights from, then we talked about the key insights, some of the key insights which I have already written here. I won't be wasting much time here. So this is the most underrated step also. Okay, so if you cannot summarize your EDA points, you did not truly understand your data. So EDA is complete only when insights are clear. So most beginners, jump directly to the machine learning professional time, spending the understanding the data. Okay, but strong EDA leads to the better features, better models, better results. So let's meet you in another video of the mini project. So this is basically a mini project only, I guess. Okay, we worked on the real data set, and if you want more such videos of like any project, like any ML project or the EDA on any real data set, just let me know in the comment section and just like this video, subscribe my channel, and do not forget to hype my video. Meet you in the next video. Till then, bye bye. Meet you guys in the next video. Bye bye.